All right, good afternoon, everyone.
Good afternoon.
So how are you guys doing today?
Pretty good.
Pretty good.
Am I your only class that you've had today?
We had a college English class.
Oh, okay, good. Good. Well, I sure appreciate you guys coming in while your school is on break. So, but anyway, I'll try to make it worth your effort here. So let's see. Who do we have missing in Moyan?
Thank you.
We're missing Jordan and Rachel.
Hey, and it looks like we have an extra calculus student in Winslow.
Hi, Grandpa. How are you?
Hey, Renell. Yeah, guess what amazing thing I did over the weekend? I became a grandpa.
Congratulations!
Thank you.
Amazing for little
Thank
Poppy.
Thank you.
I had to say hello, Grandpa Strong.
All right. Thanks, Renell.
Good to see you, Jeff.
Good to see you, too. All right. So now I forgot who was absent. Yeah. All right. So it was Jordan and who else?
And Rachel.
And Rachel. All right. And how about, let's see, it looks like we got everybody in Winslow +1. And is Aiden there in St. John's?
Yeah.
Okay. All right. I wasn't quite sure if everybody was there. All right. So did anybody else do anything amazing over the weekend? No? Well, all right. Well, I guess...
Mr. Strong,
Yes.
could we, Skylar and I didn't get to our second attempt of the chapter 4. Could we take that right after class today?
Sure.
Okay.
Yeah, let me make a note of that.
And then I won't be here tomorrow. I have a basketball game, so.
Okay, so just look for the video. I'll try to post it. I'm hoping to get everything caught up before Thanksgiving, so hopefully that video will get posted right away.
Okay.
And then I was gonna, let's see. So tomorrow I was gonna talk about the quizzes that I'm gonna post. I was gonna, let's see, it's 4. See, we did 4 through 4 is 7. Actually, for you guys, maybe we won't worry about quizzes on Wednesday. All right, but let's just focus on getting through that chapter 4 test. Now, St. John's, I know you guys lost power or something. Were you guys able to take the second attempt on Thursday or not? Or Friday, or no, Thursday.
I took both attempts, but I think I was the only
So,
one.
yeah, Aiden took both attempts. I got one attempt, and then Nathan and David weren't able to start at all.
Okay, well, will you guys send me your updated when you want it, or do you know when you want it? You want it after class
I
today?
think tomorrow, just from 150 to 250.
150 to 250. And so that's all the St. John's guys except Aiden.
Yes.
Okay. All right, and then Mogion, you guys got all squared away, right?
Yeah.
All right, wonderful. All right, well, let's go ahead and get started here today, and then we'll see where we are for tomorrow. Now, how about the student success organizers? Did everyone get a copy of that?
Yes.
Chapter 5? All right, well, thank you. Talent Aids, you guys are awesome. Appreciate you getting those out. All right, so today we are going to start in on chapter 5. On integration. Okay, so I don't know if you remember me telling you that back in the day, calculus was taught over 3 quarters in the quarter system. They had The first quarter was differential calculus, which we have actually completed. And so the rest of this semester and the first couple of chapters in the next are what we call integral calculus. So this is really the next huge idea in calculus. So integration. So we're going to start it off with area and estimating finite sums. Now let me give you a little background on this, is that, we talked about Isaac Newton and how he did like the derivative and the antiderivative, and everything was sort of based on physics, acceleration, velocity. But then on the continent, you had a guy named Gottfried Leibniz, and Leibniz was working on finding areas. Because if you think about, in areas and volumes, because a lot of things in real life it's not all rectangular or squares or circles. And so how would you find the area of some odd shape? Well, okay, so the area of a region with a curved boundary can be approximated by adding areas of rectangles. So the idea is that if you had to find the area underneath this black curve here, one way to approximate it is to use shapes that you already know. So like rectangles. And so you'd say, well, I know the formula for rectangles. So if I added up the areas of those three rectangles, that'd be pretty close. All right. So more rectangles can increase the accuracy of the approximation. So how many more would we need? How many more would you want? I mean, if you wanted to be exact, how many rectangles could you use to find the area under that curve from A to B?
An infinite amount.
An infinite amount. See, that is a calculus answer right there. An infinite amount, because in calculus, we're used to adding up infinite amounts. All right, so if we start off with just here's the function, okay? And I just use one rectangle, length times width. So here's the width of the rectangle, here's the length or the height, and we could approximate the area. But this part right here, that's your error. So this is what we call an under approximation, because there's obviously a lot of error there. Well, if we draw the rectangles in such a way that their shape goes outside the curve, then it's an overestimation. And so it's still length times width, but the idea is that you're still going to have an error, whether it's over or under. But the more rectangles you use, see these little spaces of error here are going to be less and less. Okay? All right, now, there's also different ways that we can make the rectangles. We can use the right or the left y value, depending on which height we want to use. Or this one is where we use the midpoint of each rectangle. Now, this is actually more accurate because, well, why? Why? You tell me, why would this approximation be more accurate than, say, this one? Just from a visual standpoint.
There's less area left out.
Yeah, there's less area left out, and see here you have an underestimation, but then you have an overestimation too, and it's like they cancel each other out to some degree, and so that's going to be more accurate when you use the midpoint of each one. So there's kind of different ways that you can do it. Yeah, what they call a left sum is where you use the left of the two y values. So here, this y value would go all the way up to 1. And this y value would go to 15/16. So this is using the right of these two y values. So, but you can use the left one, you can use the right one, or you use the y value that's created by the midpoint of each one. Okay? And so there's different formulas that you would use. Okay? So the lower sum uses the lower of the two y values. It doesn't matter which one is to the left or to the right. The upper sum uses the higher of the two y values. And again, by the y values, we're talking about like these two right here. These are the x values, and then these are the two y values. So when we're talking about the height of the rectangle, that's what I mean of the two y values for each rectangle. The left sum, you use the left of the two y values. The right sum, you use the right of the two y values. And the midpoint, you use the y value of the midpoint. Okay? And so it's not like you have to memorize all. They'll tell you in the problem. Use the left sum. Use the midpoint values. So it's pretty self-explanatory, but you do need some practice with each of these so you become familiar with it. All right, so here we have 16 rectangles we're using. So when it says n equals whatever, n equals 16, that's the number of rectangles. And so if I wanted to use the lower sum, then if you think of, if each of these rectangles is the length times the width is 1/16, the length is going to be the height or the y value of each rectangle. Well, since the width is always the same, what we do is we just factor that out. So we have 1/16 times each one. And then each y value, so if I'm going to use the lower sum or the upper sum, let's look at the lower sum. See here, the y value is 1, and here the y value is, well, the f of 1/16 is what I've got here. And then they're all going to go down. This function is decreasing, so the lower sum is always going to be the one on the right. So it's the f of 2/16, the f of 3/16. So all of these values then you can get from a calculator. So what we're going to do is set this up so that you see these y values in a table, in a calculator. Okay? So let me show you what that looks like. Okay, so what we do to get these y values here is we plug in the function into the y equals. So 1 minus x squared. So 1 minus x squared. And then we want the table. And so if we do second table set, and so whatever our first x value, so we look here along the x-axis here, our first x value, we're starting at 0. And then the delta table is how far we're going to go up by. And so since there's 16 rectangles from 0 to 1, then each x value is 1/16. So our delta table is going to be 1/16. Then when we do our table, so second graph, then we use all of these y values here. And so now is where you look to see, is it an upper sum, is it a lower sum, which one are you going to use? Okay. So for the upper sum, we would use 1 for the first y value. So 1, and then the second one, we'd use the second entry, on down to the last entry we wouldn't use. Okay. So if we have to find the area of any crazy region, then the idea is that depending on the number of subintervals, the number of our rectangles, we're going to get more accurate each time. Now, what I'm trying to show by this screen is that, see, look how the lower sum is fairly inaccurate until you get to about 100 rectangles. Okay, same with the upper sum. But the midpoint actually comes pretty close to the answer right away. And so the midpoint is by far the more accurate of the three. Okay? Now, we're not going to use 100 rectangles because that we have to do the calculations for that. So we'll probably do like somewhere between 4 and 10. Okay, now, how many fence posts? Now, what does this have to do with what we're talking about here? If you were going to build a fence that, let's say, is 6 yards long, and you wanted a fence post every yard, how many fence posts do you need?
Six.
Try again.
8.
Try again. You guys need to go out there and work in the farms. See, you got to start with one, right?
What was the question?
So how many fence posts do you need? If you want a new, if you want to post every yard and you're building this fence, you have to start with a fence post. Does that make sense? So then and then you're going to end with a fence post. So how many posts will you need if you want one every yard?
7.
So you'd need 7. Okay? So even though your fence is going to cover 6 yards, you're going to need 7 posts. So what does that have to do with what we're talking about?
That you can't forget 0.
Well, you can't forget 0, or wherever it ends. See, let's go back. See so you have 0 and then you have 1. So you're going to have all of those y values, but there's actually one of them that you're not going to use. Either the first one or the last one, because you're only going to have 16 rectangles, but you actually are going to have 17 y values. One to start with, one to end with. But you only have 16 rectangles, so you're only going to have 16 heights. So one of these values you don't use. So like if you're doing the left, or let's say the lower sum, you're not going to use the f of 0, which is 1. If you're using the upper sum, then you don't use the f of 1. The 15/16 is the last height that you would use. So you'd only use as many rectangles as you have. Okay. All right. So now, what I would like you to do is I want you to draw. Let's see. This is 1 minus x to the 4th. Okay. So draw that on your paper. 1 minus x to the 4th, and then I want you to cut it up into 2 rectangles. Okay, so the thing that's kind of odd about this one is as we look to, here's 1 minus x to the fourth. And so when we cut it up into two rectangles, then, let's see, that's not what I want. So the y values here, when we plug in -1, the y value is 0. And so when we say a lower sum, this is what I'm looking for over here. So a lower sum, so when x is -1, 0, and 1, when you're trying to calculate the lower sum, the lower of these two y values is 0. And so the first rectangle that you use actually is this little one right here that has no area at all. Now, I'm just trying to show you that kind of wackiness could happen. But so the area using rectangles with a 0 height, the area is going to be 0. And so using only two rectangles with a lower sum is an extremely poor choice here for an approximation. Okay? All right, so now what I want you to do is think about the same area here. And now we're going to cut it up into four triangles. 1, 2, 3, 4. And so see if you can find the sum of the areas of those 4 rectangles. Okay? So a lower sum with 4 rectangles of equal width. So see if you can find the area of those 4 rectangles.
Mr. Strong,
Yes.
are the triangles supposed to go in the red part or beneath it? Or not the triangle, it's the rectangle.
The rectangle. Hey, don't feel bad because for years I kept always saying triangles on this. So, don't feel bad about that. And I probably will say triangles sometimes too. But yeah, you want them to come under the curve. Okay? So like that as you draw it in. And it's actually good, I think, to draw in the 4 rectangles that you're going to use. Now, if you're one of those students that has colored pens or pencils, you want to break them out here because that's very helpful. So
Very cool.
yeah, just to keep everyone. Okay, so Hannah W., when you have an idea or if you get stuck, let me know.
So that where you selected them?
Mm-hmm.
I'm kind of stuck.
Okay, that's fine. So if you broke it up into fourths, let's see if I have okay. So if you broke it up into fourths, let's use the same deal here. What would be the width of each one? from -1 to 1, and there's 4 rectangles, what would be the width of each one?
1/2.
1/2. All right, so everybody good with that? Any questions on that? Okay, so now to get the height of each one, what you want to do is make a little table and say, okay, so so what would be the height when you plug in, well, okay, -1. Okay, I don't know why. Okay, there we go. So what we do is we want to expand our table to include, I'm in trouble here. Okay. Oh, I know, I did it on the calculator. So let's put in 1 minus x to the 4th. Okay. And then we said each width was 1/2, right? So that's what you want to change your delta table to. So you want to say, so do your table set, and you're going to start it at -1 this time. And then we're going to go up by 1/2, 0.5. All right, so now, and we're just using this part from -1 to 1. So here we're going to do the upper sum. So you look at these two y values here, and you're going to, one's at 0, and the other's at 0.9375. So you're going to use the upper one of those two for your height. So the first height of your first rectangle is going to be 0.9375. Oh, I've got it right here. The lower sum. I'm sorry, I said that wrong. Let me change that again. So the lower of the first two is 0. So that's your first height. Then you look at the next two. The lower of those two is 0.9375. Then you look at the next two. The lower of those is 0.9375. And then the last two, the lower of the two is 0. And so then you just calculate that, put that in your calculator, crunch it out. And so you get that as a better approximation. Okay? So for this one, we're going back to 2 rectangles of equal width. So now, when we only have 2 rectangles, what's the width of each
Bless you.
rectangle? Thank you. What's the width of our rectangle for just 2 rectangles? So if I just have 2 rectangles, what's the width of each rectangle?
1.
Just 1. Okay. So now go back and change your table and say, all right, do my table set. I'm going to start at -1, and each one's going to go by 1. And so this is going to be my table. And so now so now we use the upper sum. So we're going to use the upper of the 2 values for the heights. All right, so Denon, when you've got it, or if you get stuck, let me know.
Is it 2?
Is it 2? It is 2. Great job. All right, so the last one, I want you to go ahead and do D before class tomorrow, and then we'll go over it. And then if you have any other questions, then we'll do that. Okay? So I want you to do part D for tomorrow. All right. So an application of this is where estimating the height of a projectile. So given the velocity function of a projectile, the summation technique can be used to find the distance divided by the height. See, here's the velocity function, the curve or whatever. If we find the area under it, then it could be the distance. And then the height, the time is the x-axis, the height is the y-axis. So when we find the area under a velocity curve, we can find a lot of information about the physics of the... Now, who was it? Somebody in here was talking about they did that in their physics class. Was it you, Joey? That
I
found,
don't remember.
that found the area under a velocity curve? Somebody said something like that.
Yeah, we did do that in ours.
Yeah, so this is exactly the idea of what you did in your physics class, finding the area under the velocity curve. What we're doing is we're just kind of making it into a calculus, but this is exactly what you did. Okay? So let's say it says estimating the height of a projectile after 3 seconds using 3 rectangles. Now we're going to use the midpoint formula for this, and we're going to use this as my velocity function. Okay? Now, so the big idea is this. If this is the velocity function, to estimate the height at any time, we're going to calculate the area under the curve. Okay? Now, what's a little different when you're setting it up, and why the simple graph can be very helpful, is when you're using 3 rectangles for 3 seconds, then obviously the width of each is 1 second. But we're going to use the midpoint method, okay? So the midpoint method. So with the midpoint method, then what we need to do is find the y value at each midpoint. So at 0.5, 1.5, and 2.5, okay? So to get these values. All right, now let me show you how you can use the calculator to do that by changing this slightly. If you put in the function into your y equals, so we're going to have, so 160 minus 9.8 t, and that the units are meters. So I'm just going to use x instead of t. All right, now, what I want is the y values for each of these at the midpoint. So when you're using the midpoint method, when you set up your table, it's usually better if you change the auto to ask. Then you can just type in the specific x value you want, and then it'll spit out the y value. Okay, so you do your table, nothing shows up. So then you do your 0.5, your midpoint of the first rectangle. See, now the width is still going to be 1. So you're still going to have a 1 out front for all of these. But to get the y value, you're typing in the midpoint. So for the first one, 0.5. Oops. Let's try that again. 0.5, 1.5, and 2.5. So you use the ask method to get specific values. And then when you do the math, 1 times all of these, so just add those up. So that total amount, that's the height of the object after 3 seconds. Okay. All right, so go ahead and try practice 2. So it's just a variation on that.
Mr. Strong. Is he talking?
Yes, Chloe?
What do you put for the table set if it's 4?
Okay, so you're doing it for 4 seconds, right?
Mm-hmm.
So then the width of each one is going to be 1. So in your formula, but then as you draw it out, let's see, that's the best I'm going to get. So what would be, so for each second interval, what's halfway? So from 0 to 1, what's the midpoint?
0.5.
0.5. And then from 1 to 2?
0.5.
So it'd be 1.5.
Oh, right,
And then
right.
2.5. So your table will look like that. Does that make sense?
Yes, thank you.
Okay. Thank you for that question. So All right, Joey, do you have an answer? Or are you stuck? Or you need a little more time? Or what?
Okay, I got 321.6.
321.6, dude. Excellent. Okay. Exactly right. Okay. So, any questions? Anyone need any help setting it up? So again, here's your width is 1 for all of them. And then using your y values, okay, these are the heights. So it's length times width, and you're doing 4 rectangles. Okay. All right. Great job, Joey. Any other questions on that one? All right. Okay, the displacement of an object can be found by multiplying the velocity by the change in time. Okay? Now, so the way that we say that in math is the velocity v of t, and then the change in time is delta t. Okay? Now, so I know that sounds kind of odd, but displacement, think of that as your rectangle. And your width of your rectangle is the change in time. The height of your rectangle is the velocity. So length times width, that's going to be displacement. Now, displacement is a little different than distance. Okay? So like if I walk across this room here toward the camera 3 steps and I walk back 3 steps, what's my displacement?
0.
0. But what distance have I traveled?
6.
6 steps. So it is a little different. So, but the idea is displacement is the velocity multiplied by the change in time. Okay? So let's see if we can do a problem with that. Okay? It says a rock is blown straight up by a dynamite blast. The velocity of the rock at any time during its motion is, okay, so here's our velocity equation. What is the rock's displacement after 8 seconds? Okay, so not the distance, but the displacement. Okay, so here, let's say we're going to use 16 subintervals. So that means 16 rectangles with the lower sum. So when we do our table, so if we're doing an upper sum or a lower sum, that's when we want to do the auto, because it's going to go up the same amount, 0.5. What? How do I know that the delta x, the change in x, is 0.5? Where it doesn't say that anywhere in the problem. Where do I get that? Delta x is 0.5. That's like the width of each rectangle is 0.5.
There's 8 seconds, and then you have 16 subintervals, and so that's just 1/2 for everything.
Yes. So 8 divided by 16. So in general, that's how you do it. You take the total, the distance along the x-axis divided by how many subintervals you want. So you get your 0.5, and so you'll go up each time. And then you get the y values. So since I'm using a lower sum, each time you choose which one you're going to put in by which one's lower. So here I'm picking the 144, the 128, the 112, and so on. Now, this is a little tricky right here, because when you get down here, the lower one is 0, but here the lower sum is negative 16. Okay? So you got to be a little bit, when you start dealing with the negatives, you got to watch out. And so then you get a total displacement is 192 feet. Now, when we compare that to the distance, so on the distance of an object can be found by multiplying the speed by the change in time. So remember, speed is the absolute value of the velocity. So all those negative values that we had in our table, you take the absolute value of. Okay? So now, for tomorrow, well, let's start, but we probably aren't going to be able to finish. I want you to do practice 3, where you're trying to, same problem, find the rock's distance after 8 seconds. So 16 subintervals, lower estimate again. It's the same as I did in the example. So if we drop off before we're done, just have this ready for tomorrow. And then I'm going to set up right after class. I'm going to set up Chloe and Skylar for the chapter 4 test. Right?
Thank you.
You bet.
And Mr. Strong, are we doing we're doing the test from 150 to 250, right?
Tomorrow.
Yes.
Okay, correct.
Okay, thanks.
You bet. All right, well, let's just go ahead and sign off. So we'll see you guys tomorrow, and we'll start with that problem. All right? So have a great afternoon.
Bye, Mr. Strong. Have a great afternoon. Yeah,